Hello everyone. Today I am here with you all with first chapter of class 8th maths curriculum, that is your rational numbers. In our previous classes we have learned what natural numbers are, what are whole numbers and what integers are. In this video we will be learning what rational numbers are and what all are the properties of the rational number. So let's start with the topic, that is your rational number. So what rational number is? First of all, rational number is denoted by your letter Q. Rational number is denoted by your letter Q. Q denotes over here is your quotient. So all the numbers which can be represented in the form of P upon Q, where Q is not equivalent to 0 and P and Q are any integers. Such type of numbers are known as your rational numbers. All the numbers which can be represented in the form of P upon Q, where denominator Q is not equivalent to 0 and P and Q are any integers, such type of numbers are known as your rational numbers. If we are going to see over here, all the natural numbers, all the whole numbers and all the integers comes under the category of your rational number. See, if I am going to say minus 5, so minus 5 is even a rational number because minus of 5 could be written as minus 5 upon 1. Over here, value of P is your minus 5 and value of Q is your 1. 0 is even a rational number. 7 upon 5 is even a rational number. If we are going to say 9 is even a rational number because 9 could be written as 9 upon 1 also. So all the numbers which can be represented in the form of your P upon Q, where Q is not equivalent to 0 and P and Q are any integers, such type of numbers are known as your rational numbers. Now let's see the properties of your rational number. Properties of rational numbers. First of all, we will be seeing the first property, that is your closure property. We have learned the closure property for your whole numbers, even for the integers, even in our previous classes. Here we will be learning this closure property for your rational number. So we will be checking the closure property for all the four operations, that is your addition, for your subtraction, for multiplication, and for your division. For all the four operations, we will be checking the property or closure property of your rational number. What your closure property says, that if there are two numbers, suppose A and B are any two rational numbers. We have taken any two rational numbers and the numbers are your A and B. Then sum of A and B, for addition if we will be checking, then sum of A and B. Let's check whether it is a rational number or not. So suppose I am saying value of A we are taking as 2 upon 3 and value of B suppose I am taking minus of 3. So minus of 3 could be written as minus of 3 upon 1 even. So if we have taken A and B any two rational number, then sum of these two rational number will be A plus B. A plus B will be 2 upon 3 plus minus 3 upon 1. We have added both the two rational numbers. So LCM will be your 3. It is your 2 minus 1 multiplied by 3 will be 3. So 3 multiplied by 3 will be your 9. 2 minus 9 will be your minus of 7 upon 3. And minus 7 upon 3 is even a rational number. So whatsoever the two rational numbers you will be taking, the sum of these two rational number will always be a rational number. So sum of two rational number is always a rational number. So we will say that rational numbers are closed under addition. Sum of any two rational number will always be a rational number. So we will be saying that rational numbers are closed under addition. Now if we will be checking for subtraction, again two rational numbers we have taken. Suppose we have taken these two rational number only, A and A, value of A is your 2 upon 3 and value of B is your minus 3 upon 1. So subtraction means, subtraction says that if we are going to subtract these two rational number, what the value we will be getting. So what the value of A minus B will be? A is your 2 upon 3 minus value of B is minus 3 upon 1. So this will turn to 2 upon 3 plus minus minus will become plus 3 upon 1. If we will be solving it further, 3 will be the LCM. It will be 2 plus 3 3s are 9. That is your 11 by 3. So 11 by 3 is even a rational number. So when we will be subtracting any two rational number, the result will even be a rational number. So we will be saying that rational numbers are closed under subtraction. Now let's check it for multiplication even. The same numbers we have taken. So we will be multiplying A and B. The result will be your 2 upon 3 multiplied by minus 3 upon 1. So 3 and 3 both are going to cancel. Minus multiplied by your 2 minus 1 multiplied by 2 will be minus of 2 upon 1, or we can say minus 2 even. So whatsoever the number of A and B we will be taking, whatsoever the two rational numbers we will be taking, the product of these two rational number will always be a rational number. So we will say that rational numbers are closed under multiplication. Now let's check for division. If we will be dividing these two rational number, the result will be a rational number. 2 upon 3, A divided by B, we are saying A is your 2 upon 3 divided by B is your minus 3 upon 1. So we will change this division sign to multiplication sign and we will reciprocate the number. So it will be minus 1 upon 3, that will be your minus 2 upon 9. This is a rational number. But if value of B is 0, if value of B is 0, in that case A divided by 0 is not defined. It is not going to be defined. It is not defined. So we will say that rational numbers are not closed under your division. A divided by B, it is not always be a rational number. Not always a rational number. The value is not always a rational number. So rational numbers are not closed under division. What we will be saying is that rational numbers are not closed under division if the value of B is any other number except 0. So for all those values, your A divided B will be a rational number only. But if the value of B is 0, in that case, it is not a rational number because this value will not be defined. So we will be saying that rational numbers are not closed under division. So what we will be saying it that rational numbers are closed under addition, for subtraction even, for multiplication even, but not for division. And if the value of B is non-zero, then it will be closed for division also. But B could be a 0 because A and B could be any of the rational number, and 0 is even a rational number. So we will be saying that rational numbers are not closed under your division. Now let's understand the second property, that is your commutativity for your rational numbers. Again, we will be checking for all the operations, that is your addition, subtraction, multiplication and division. Again, we are assuming that there are two rational numbers. Suppose A and B are any two rational numbers. We have taken any two rational numbers. One of the rational number is your A and another rational number is your B. So we will be checking whether A plus B is equivalent to B plus A or not. That means if we are going to change the order, then whether the sum of these two rational number will be same or not. Again, we will be assuming, suppose we are taking A as your 3 upon 7 and we are taking value of B as your say 2 upon say I am taking 5. So if these two are the rational number, one of the rational number is your 3 upon 7 and another rational number is your 2 upon 5. So if we will be adding these two, A plus B, in this order, so sum will be 3 upon 7 plus 2 upon 5. LCM will be your 35, 5 7 is 35. So 5 multiplied by 3 will be your 15 plus 7 multiplied by 2 will be your 14. 15 plus 14 will be your 29 upon 35. This is the sum of your A plus B, A and B. Now, if we will change the order, we will be writing B plus A. In that case, it will be 2 upon 5 plus your 3 upon 7. Again, LCM will be your 35 only. 7 2s are your 14 plus 5 threes are 15. That is your 29 over 35. So we can see that value of a plus b is equivalent to your b plus a. Whatsoever the values of a and b we will be taking, if a and b are any two rational number, so for every value of a and b, always and always a plus b will be equivalent to your b plus a. That means if we are going to change the order, then there will not be any difference in their sum. Their sum will remain same. So we will say that addition is commutative for rational numbers. For all the rational numbers, whatsoever the two rational numbers we will be taking, always and always if we will be changing their order, then also their sum will remain same. So we will say that addition is commutative for your rational numbers. Now let's check for your subtraction. That means a minus b, whether it is equivalent to your b minus a or not. We will be checking it. So first of all, we are subtracting a minus b. Suppose we have taken the same numbers. Value of a we have taken as 3 upon 7 and value of b we have taken as 2 upon 5. So a plus a minus b, we are checking for subtraction. So a minus b will be your 3 upon 7 minus 2 upon 5. So LCM will be your 35. 5 threes are 15 minus 7 twos are 14. That will be 1 upon 35. Now b minus a will be, b is your 2 upon 5 minus a is your 3 upon 7. LCM will be 35. 7 twos are 14 minus 5 threes are 15. 14 minus 15 will be minus 1 upon 35. So we can see over here value of a minus b is 1 upon 35 and value of b minus a is your minus of 1 upon 35. So these two are not same. So we can see a minus b is not equivalent to your b minus a. If we are going to change the order in subtraction, then the your difference of the two numbers will not be same. It is coming different. The number over here, it is positive 1 upon 35 and it is your negative 1 upon 35. So the difference of the two rational number will not be same if we are going to change the order of these two numbers. So we will be saying that subtraction is not commutative for rational number. Subtraction is not commutative for rational numbers. Now let's check it for multiplication. Again, if a is 3 upon 7 and b is your 2 upon 5, what we will be doing is, first of all, we will multiply a and b. A multiplied by b will be 3 upon 7 multiplied by your 2 upon 5. 3 multiplied by 2 will be your 6 upon 5. 7 is your 35. Now if we will change the order and we will write b multiplied by a, so its value will be 2 upon 5 multiplied by 3 upon 7. That will be 2 multiplied by 3 will be 6 upon 5. 7 is your 35. So if we have changed the order, then also their product is same. We have taken any two rational number if we will be taking and we will be multiplying it, the product will remain same if we will be changing the order also. Changing of the order does not make difference in the result, that is your in the product. So we will be saying whatsoever the two rational numbers we will be taking, if we will be changing their order, then also their product will be same. That means a multiplied by b will be equivalent to your b multiplied by a. So we will be saying that multiplication is commutative for your rational number. Addition is commutative. Along with that, multiplication is also commutative for your rational numbers. Now let's check for division. First of all, we are writing a divided by b. We are checking for a divided by b. A is your 3 upon 7 divided by your 2 upon 5. So it could be written as 3 upon 7 multiplied by your 5 upon 2. When we will change the division sign to multiplication sign, your divisor, it is going to reciprocate. So it will become 5 threes are 15 divided by 7 twos are 14. 15 upon 14 is the value of your a divided by b. Now if we are going to change the order and we will be writing b divided by a, so its value will be b is your 2 upon 5 divided by a is your 3 upon 7. So it will be 2 upon 5 multiplied by 7 upon 3. This 3 upon 7 is going to reciprocate. So it will be 7 twos are 14 divided by 5 threes are 15. So we can see over here A divided by B was 15 upon 14 and B divided by A is your 14 upon 15, which is not equal, which is not same. So A divided by B is not equivalent to your B divided by A. So we will be saying that division is not commutative for your rational numbers. So what we can conclude over here, that addition and multiplication is commutative for rational numbers. That means in case of addition and multiplication, if we are going to change the order, then also their sum and their product will remain same. But subtraction and division is not commutative for your rational numbers. Now let's understand the third property, that is your associativity for your rational number. Again, we'll be checking for all operations, that is your addition, subtraction, multiplication and division. Now in your associativity, suppose we are taking any three rational number. Instead of 2, we are taking any three rational numbers. A, B and C are any three rational number. If these three are the rational numbers, then according to associativity, let's check it for your addition. That means in associativity, if your grouping is changed, whether the sum will be same or not, whether the difference will be same or not, whether the product will be same or not, or whether the quotient will be same or not, that we will be checking. Now here A plus B plus C. Here first of all we have taken the group of B and C. First of all we will be adding it, and then whatever the result is there, we will be adding the sum with your A. Whether it is equivalent to your A plus B plus C or not, that we have to check. Now suppose we are saying that the value of A is your, we are taking 7, value of B we are taking as your say 5, and value of C we are taking as minus 3. All these three are your rational numbers only. We have taken A is equals to 7, B is equals to 5 and C is equivalent to minus 3. Now first of all we are taking the LHS part, that is your A plus B plus C. So value of A plus B plus C will be A is your 7 plus B is your 5 plus minus will become minus, or we can say first of all I am writing plus sign over here, then C is your minus of 3. So it will be 7 plus 5 minus 3. Plus minus will become minus. So it will be 7 plus 5 minus 3 will be your 2. That is your 9. Value of your this part, LHS part, that is A plus B plus C is your 9. Now let's check the RHS part, that is your A plus B plus C. What the value will be? A is your 7 here, B is 5 plus C is your minus of 3. So 7 plus 5 will be your 12, plus minus will become minus, minus of 3, 12 minus 3 will be your 9. So we can see over here, if we have changed the grouping, then also sum of these three rational numbers is same. We have changed the grouping over here. First we had taken the group of B and C, and here we have taken the group of your A plus B. But in both the cases, your sum of three rational number is equal. So we will say that addition is associative for rational numbers. Whatsoever the rational numbers we will be taking, whatsoever the values of A, B and C, any of the rational number we will be taking, for each and every condition, your A plus B plus C will be equivalent to your A plus B plus C. So we will say that addition is associative for your rational number. Now let's check for your subtraction. So what the equation will be over here, A minus, instead of plus we will be taking minus now, A minus B minus C. We will be checking whether it is equivalent to your A minus B minus C or not. First of all, let's check it out. We can't say whether it will be equal or not. So we are not writing any sign. We will be checking this part and we will be checking this part. First of all, here A minus B minus C. What the value will be? A is your 7 minus B is your 5, then minus C is your minus of 3. So this will be 7 minus, in the bracket 5, minus minus will become your plus of 3, That is 7 minus 5 plus 3 will be your 8. That is your minus of 1. Now, if we will be taking A minus B minus of C. So, what the value will come? A is your 7, minus of B is your 5, then minus of C. C is your minus of 3. So, it will be 7 minus 5 will be your 2, minus minus will become plus 3, that is your 5. So, here value of A minus B minus C was your minus of 1 and value of A minus B minus C was your 5. So, we can see that value of this A minus B minus C, first we have taken the group of B minus C and then we have taken the group of your A and B. So in these two cases the difference is not coming equal. So we will say that subtraction is not associative for your rational numbers. Subtraction is not associative for your rational numbers. Now let's check for multiplication. So in multiplication, the LHS part will be A multiplied by B multiplied by C, and the RHS part we will be taking group of your A and B and then multiplied by C. So first of all, we will be taking A multiplied by B multiplied by C. Value of A is your 7, multiplied by B is your 5, multiplied by your C is your minus of 3. So it will be 7 multiplied by 5 multiplied by it is your minus of 3. So 5 3s are 15, 15 and that too it is minus of 15. So we will be writing minus of 15. 5 3s are 15, 15 is your minus of 15 it will be. So it will be 5 7 is your 35, carry over 3, 7 1 is 7, minus of 105 is the product of these three rational numbers. Now if we will be taking group of A and B first and then multiply the product by your C, then what the result will be? 7 multiplied by 5 multiplied by your minus of 3. 7 multiplied by 5 will be your 35 multiplied by minus of 3. 35 3s are your 105, that to minus because minus sign is over here. So we can see that if we have changed the order, then also product of three rational number is equal. Changing of the order is not making any difference in the product of any three rational number. So whatsoever the three rational number we will be taking, for each and every rational number, A multiplied by B multiplied by C will be equivalent to your A multiplied by B multiplied by your C. So what we will be saying is that multiplication is associative for your rational numbers. As your addition was associative for rational numbers, similarly multiplication is also associative for your rational numbers. Now let's check for division. For the division, your statement will be A divided by B divided by C. And in the RHS, it will be your A divided by B divided by C. We have to find these values. So first of all, we are taking A divided by B divided by C. Value of A is your 7 divided by B is your 5 divided by your minus of 3. So it will be 7 divided by 5 divided by minus 3 will be your 5 multiplied by minus 1 upon 3. That will be your minus of 5 upon 3. Minus of 5 upon 3 it will be. Value of this will be a minus of 5 upon 3. Now if we will be dividing it, so this division sign will change to multiplication sign and this number is going to reciprocate. So it will be 7 multiplied by minus 3 upon 5. So it will be minus of 7 3s are 21 over 5. This is the value of A divided by B divided by C. Now let's check for your A divided by B divided by C. First we had taken the group of A divided by B, that is your 7 divided by your 5 divided by minus of 3. So 7 divided by 5 will be your 7 multiplied by 1 upon 5, that will be 7 upon 5. This 7 divided by 5 means your 7 upon 5 divided by your minus of 3. Now this division sign will change to multiplication sign and it is going to reciprocate. So it will be minus of 7 upon 15. So we can see over here that the value of A divided by B divided by C was your minus 21 by 5 and value of this is your minus 7 upon 15, which are not equal. So we will be saying that if we are dividing any three rational number, then their quotient is not same if we are going to change their order. So we will be saying that division is not associative for your rational number. So what we can conclude over here is that addition and multiplication is associative for your rational numbers, but subtraction and divisions are not your associative for rational numbers. Now let's understand what is distributivity of multiplication over addition and over subtraction. So what this property says, that if A, B, C are any three rational number, we have taken three rational number, that is your A, B, C, we have taken three rational numbers, then A multiplied by B plus C will be equivalent to A multiplied by B plus A multiplied by C. This is your distributivity of multiplication over addition. Now suppose we are taking value of A as your say 3, value of B as 2 upon 3 and value of C suppose we are taking as your 1. In that case, A multiplied by B plus C. What the value of A multiplied by B plus C will be? It will be 3 multiplied by 2 upon 3 plus 1. Instead of A we have taken 3, instead of B we have taken 2 upon 3 and instead of C we have taken 1. A, B, C could be any three rational number. So in that case the value will be your 3 multiplied by, first of all we will be solving the bracket, 3 will be the LCM over here, it is your 2 plus 1 multiplied by 3 is your 3, that is 3 multiplied by 2 plus 3 will be your 5 upon 3. 3 and 3 are going to cancel, it will be your 5. Now let's check for your RHS part, that is your A multiplied by B plus your A multiplied by C. So A is your 3 multiplied by B is your 2 upon 3 plus A is your 3 multiplied by B is your C is your 1. So these three are going to cancel. It will be 2 plus 3 multiplied by 1 will be 3. That is your 5. So we can see over here that distributivity of multiplication over addition says that if it is your A multiplied by B plus C, then it could be written as A multiplied by B plus A multiplied by C. Similarly, what is the property of distributivity of multiplication over subtraction? According to it, A multiplied by B minus C. If there is subtraction sign in between, then it could be written as A multiplied by B minus A multiplied by C. We can prove it even just as we have done just now. First of all, we are taking A multiplied by B minus C, LHS part. The same values we are keeping. So it will be A is your 3 multiplied by B is 2 upon 3, C is your 1. So it will be 3 multiplied by, LCM will be 3 over here. It is 2 minus 1 multiplied by 3 will be your 3. So it will be 3 multiplied by 2 minus 3 will be your minus 1 over 3. 3 and 3 both are going to cancel and it will be your minus of 1. Now take the RHS part, that is your A multiplied by B minus A multiplied by C. A multiplied by B is your 3 multiplied by 2 upon 3 minus of A is your 3 multiplied by your 1. 3 and 3 going to cancel. It will be your 2 minus 3 multiplied by 1 will be 3, that is your minus 1. So we can see that its value is minus 1 and its value is even minus 1. So whatsoever the values of A, B, C will be there, if A, B, C are any three rational number, then according to distributivity of multiplication over addition, A multiplied by B plus C could be written as A multiplied by B plus A multiplied by C. Similarly, A multiplied by B minus C could be written as A multiplied by B minus A multiplied by C. Now let's see what additive identity is. Additive identity. Additive identity for any rational number is your 0. Why it is 0? We are assuming that A is any rational number. If A is any rational number and if we are going to add 0 in it, or if in 0 we are going to add your A, in all the cases your result will be A only. That's the reason additive identity for any rational number will be your 0. Similarly, what multiplicative identity is? Multiplicative identity. Multiplicative identity for any rational number will be your 1. Again, we are assuming that A is any of the rational number. Why multiplicative identity is 1? Because if we are going to multiply A by 1 or we are going to multiply 1 by your A, the result will be the number itself, that is your A. That's the reason for every rational number, the multiplicative identity will be 1 and your additive identity will be your 0. These are the properties of your rational numbers. We have learned about closure property, commutative property, associative property, distributive property of multiplication over addition and subtraction, what additive identity is and what multiplicative identity is. Now let's see if there are any two rational numbers are given. Suppose I am saying that any of the rational number is, suppose 2 is a rational number and 3 is a rational number. If there are any two rational numbers are given, between these two rational number, we can find infinite of rational numbers could be there, could be written between any two given rational number. So what it could be? See, 2 and 3. So 2 could be written as, if we are going to convert this into equivalent fraction, right? So this could be written as 2 multiplied by 100 divided by 100. We can write it as, so it could be written as 200 over 100. Similarly, this 3 upon 1 could be written as multiplied by 100 and divided by 100. So it could be written as 300 by 100. So between these two rational number, the numbers will be your 201 over 100, 202 over 100. Similarly, we can find infinite of rational numbers between any two given rational numbers. And the general formula for finding the rational number between any two given rational numbers A and B is your A plus B by 2. This is how we can find the mean also. So if there are two rational number, one is your A, another is B, then the rational number which will lie exactly in between these two rational number will be A plus B by 2. This is all about your rational numbers. Hope it is clear to you. Hope you have understood what rational numbers are and what all are the properties of rational number. Soon we'll be coming with the more videos on other chapters of class 8 maths curriculum. Thank you.